Hello, everyone. Welcome to this webinar on designing for sustainability in affordable housing. Of course, we're looking at affordable housing in the developing world, not in the developed world, and particularly from the Indian perspective, because that's where I practice and that's where I work. Now, what's happened historically is that our formal system of town planning and urban development has not been designed to provide for legitimate, secure, environmentally safe housing for the poorer half of our citizens, a large proportion. And so we say there's a housing shortage. And the issue is, how do you make it affordable for people with very little income? Most of the shortage in housing, where there's not adequate or proper housing, where people are living in bad circumstances in slums, etc., is amongst the bottom 1/3 of the economic pyramid of society. And the lowest in that level, in that pyramid, are the worst sufferers. So here's an issue. You have to reach the threshold of affordability in your solutions. And that's where the bulk of need for housing in our cities still persists. Now, let's not forget this. This is extremely important. That if we are talking of urban development and housing, the two together are meant to be a solution for poverty alleviation. These are interlinked processes where urban development, which provides affordable homes in the city, will produce poverty alleviation and greater equity in our social fabric. Nothing is affordable in housing unless it has an advantageous location and it has a live and work affordable shelter provided within the fabric of the city. Once you have that, then you get efficient economic processes, you get a rapid distribution of wealth, and that results in poverty alleviation. So we should now say that if you can take care of the cost of land and building, land is a big issue, I'm not going to talk about that today, and if you can be careful in the use of your resources, whether it is land or energy or materials, and you can make things in a low carbon manner, whether it is the use of materials or it is the transportation of the city, that is when affordability and sustainability become complementary. That is my assertion. A combination of resource efficient and low carbon construction with compact urban morphology, that is what produces affordability actually, and low carbon city transport produces a low carbon and affordable urban system. Now, there's a big debate going on in our part of the world, and there's a move somehow. People think that we have to go high-rise. Everything has to be high-rise because our land is short, and that's modern. But we thought, oh, hold on, let's have a look at that. So we did some research, looking at low-rise affordable housing, medium-rise affordable housing, and even high-rise buildings which are supposed to be affordable, but they're being built in the name of affordability. We looked at real projects, and we analyzed them thoroughly on different parameters. So here's an interesting one. If you look at the embodied energy intensity, if there are 233 units of embodied energy per square meter in a 4-story or 5-story building, there are 310 units of embodied energy in a tall building, say 12 stories tall. So you can see, as you build taller, you use more steel, you have to resist more earthquake forces and wind forces, and also gravitational forces, and it just becomes much more expensive in embodied energy terms. Higher carbon dioxide emissions as you go taller. Operational energy, well, as you go taller, you become dependent on pumps and lifts much more, and also on fire safety systems. And so the cost of operating a building just to make it work, if you're taller, is so much higher, 4 to 5 times higher as compared to a low-rise building, which is 4 to 5 stories high, which is walk-up. So here we are operational cost of energy goes up. Again, higher carbon dioxide emissions. What about maintenance cost? Well, as the buildings age, you can look after low-rise building easily. But the tall buildings with all the complex systems and difficult access on the outside of walls and windows and so on, it's very much more expensive. So maintenance expense is much higher when you're talking about high-rise buildings. And this is the real nugget. Think of 4 to 5 stories high buildings with a rooftop which has cleared the tree line and is open now to the sun. Plenty of sunshine in our part of the world, plenty of sunshine. Now, the calculation shows that if you can give 60% of your rooftop to solar PV, 80% of your energy demand, annual energy demand, can be met by that solar rooftop PV system. And of course, as you build taller and taller, that ratio becomes less favorable. And if you go very tall, you can't possibly do anything more than 30% of your energy demand met by solar PV. And of course, your energy demand also goes up as you build taller and taller. So this is a very important thing. It just tells you, it's a hint, that here's an urban fabric, 4 or 5 stories tall, clears the tree line, access of solar for solar energy production, solar PV-based energy production. You have a potential solar city format. Another very important thing in our part of the world, in many developing countries too, most of our people are below the age of 15 today. 60% of the population is like that. Now, this young population, as it is growing, needs more space immediately outside the house, near the house, not necessarily within their homes. You can't afford a big home because it does cost a lot to build. So you have a small home, but it becomes livable if you have access to outdoors, livable outdoors, whether it is terraces or balconies or gardens in streets. Again, 4-story high, go to the rooftop, go out onto the street and garden, you have the access. So socially, from the point of view of our demography, there is a great advantage in low-rise, high density. When you put all of these factors together and you do a comparison, whether it is open area per person, embodied energy, operational energy, solar rooftop potential for solar PV, construction costs, construction time, and most important, at the bottom of the list, you'll see disaster and breakdown resilience. Who wants to live in a tall building if there's a big earthquake, if there's a fire, if there's an electricity failure, if water doesn't come? You know, it's really not a sustainable way of living. It's not the positive, desirable way of living. The real answer is optimize with 4 to 5 story. So if we talk about the DNA of a low carbon, affordable city, the DNA is low rise, 4 to 5 stories high, high density. And for small homes, this really works very well. You can get very good densities. The construction cost is very, marginally higher than building small homes, say 1 or 2 stories high. Excellent solar potential. And very important, look at the bottom of this list. It is the best opportunity for the distribution of wealth through the construction process, because the grain of development, the size of each project is relatively small. Many more people with simpler skills and smaller contractors can participate as compared to the big, high-rise type of construction industry. So here it is. This is the DNA of a low-carbon, affordable city. Now let's move on to the making of the house itself. Group housing is the answer. Compact group housing. Compact form and arrangement is a way of economizing, sharing walls, reducing the perimeter of the building in relation to its floor area, and managing that architecturally really well. So here it's a system of a doubly loaded corridor where you have adjacent bays which can be connected to one another. You can have small homes, 1-bay homes, 2-bay homes, 3-bay homes, 4-bay homes, according to the demand. And this can even change over time. Very flexible, very simple system. But really, compactness is the solution here. And you can try other variants of this. Like this is a project that was built in Chennai. Here's a solution where The passage in the middle, around which you have houses on either side, is like a street up on the third or fourth floor. And then along the street, at one or two locations, there might even be a lift, an elevator, so that in case somebody is very ill or somebody is very old or somebody passes away, there's a dignified way of vertical mobility. Very affordable, but here's a solution for making vertical mobility also affordable. But once again, don't forget, compactness is the basic principle. Another principle in all of these designs is that, you're going to start with a small home today, but tomorrow, as your income improves, you might want a bigger home. Even the family dynamics change. You start off as a young couple, and the family grows. Then parents might want to come in. Household size increases. Then, as you retire, children go away. Once again, the household size shrinks. So, if in the system of construction, the structural system, the circulation system, and the system of vertical threaded services, wet services and electrical services, if you can design that in such a way that over a period of time, these houses can change their internal character. They can expand and shrink, borrow space from the neighbor or give up space to the neighbor, like that. That must be done. Then it is truly robust and sustainable over 50 to 60 years of the life of the building, because the family is going to change, the household is going to change. Another system that was doubly loaded corridor, stacked 4 to 5 stories high. This is walk-up apartments, stacked 4 to 5 stories high once again. But here it is a row housing system. Again, see the compactness and the sharing of walls produces economy. And in this case, you are stacking them back to back. One set of houses facing in one direction, another set of houses facing in the opposite direction, with the courtyard in the middle to provide light and ventilation. This is also a very good compact method. And you can try many variants of this kind of method, depending on the size of house. Once again, the structural system can be so designed that you can borrow and steal and exchange adjacent spaces from the next house. Now, one great advantage of compactness, especially in climates like India, where it tends to be very hot, when the days are usually very hot for most of the year in most parts of the country, you need to be protected from the outside elements. So compactness leads to better protection from the outside and makes it, and therefore, insulation on the outer walls becomes simpler for you to achieve, so long as you provide for sufficient ventilation through your spaces. This compactness reduces the demand for cooling or heating in the annual cycle. So compactness, once again, is from a climatic point of view, is beneficial. It also reduces cost at the same time. Now, it is very important that you optimize what we call the passive design strategies for climate conscious design. Very, very important, because that will reduce in the future your demand for air conditioned comfort. If you let it go, if you don't take care of it, that demand is going to increase exponentially, and you will have huge summer peak loads, which our electricity supply systems will not find possible to meet. So here's the rule of 3 for passive design: shade, insulate, and ventilate. This is for warm climates, of course. Shade, so that the sun doesn't come directly in. Shade also such that the impact of the sun, whether it is on the roof or on the walls, is also reduced. Insulate, definitely insulate the roof. Maybe insulate the walls too, especially the walls that are facing the rising and the setting sun. And do allow for ventilation. Allow for ventilation right across the space, so that when it is pleasant outside, whether in the evenings or early mornings, through the night, or during pleasant seasons, you should be able to make the house relatively transparent, allowing the breeze to move through and bring the benefit of the outside environment to the inside of the house. Very simple rule, easily followed, but you have to pay some attention to it. And here's the project in Chennai that I was earlier talking about, where Most of the building blocks following the doubly loaded corridor principle are facing north and south so that the impact of the sun shining on the walls is reduced. Very little of it is exposed to the rising sun on the east and the setting sun on the west. But not all of them can achieve that ideal. There will be some that face the wrong way, unfortunately, but that has to happen because of the nature of the site. So, what do? Well, first, you follow the principle of compactness. Second, make sure that all the windows and balconies are properly shaded outside, not from inside, but from outside. Design of windows is probably the most important thing, which is being nowadays, in the name of modern design, is being ignored. Sliding windows without any shading protection outside. If the windows can be subdivided into 2 or 3 components, so much the better. You open it according to your need, according to the nature of the day, according to the nature of the climate or the season, and make it lightweight. Make it lightweight so that the sun that is intercepted by the window shade system does not heat up so much and does not transmit that heat into the main fabric of the building itself. That's a principle to remember. Well, here's a project that was done. Notice the slender frames outside the balconies and outside the windows. Can you see them? Notice those frames. All windows have these little frames outside, and all the balconies have these little frames outside. Now, this is what these frames allow you to do. Very low cost, very simple, but it really is the framework on which you can hang any kind of shading system, which can be variable. You can operate it yourself. You can, and this allows you to take care of any orientation. If you happen to be facing southwest or even westward, well, if you have shading systems like this, you can protect yourself from the afternoon sun, and you can raise it up during the daytime. So a simple device like this goes a long way in providing low-cost passive design for comfort. But this is what is happening in the market. So talking of building sense now, today, some of us in our profession of architects are producing this sort of nonsense. So I'm appealing to all of them. Just watch yourself. In the name of modernity, of fashion, watch yourself doing this. This is totally anti-social, anti-environment, and not something that is going to help us go away from climate change. Insulation of walls is easily possible, and it's been done in this low-cost housing project in Gujarat within the budgets that were permissible in a governmental project. Roof also is insulated here. Now we move on to something else very important. About 55 to 60% or even 65% of the total cost of simple buildings is accounted for by its structural system. If you want to save cost, make the structural system really efficient. If you want to make the structural system really efficient, well, reduce the quantum of steel that is consumed. Reduce the steel intensity of the structural system. That's the key. You reduce the steel intensity, you reduce embodied energy, thereby you reduce the carbon dioxide emissions in the construction of the building substantially, because steel is a real culprit. So here's a very simple device, which has been devised for a project that is supposed to happen in Tamil Nadu again, an interlocking concrete block. You can design the concrete strength according to how tall the building is going to be. You can design a stronger block for low floors and a lighter block or a less strong block for the upper floors. But it interlocks like this. And you assemble this interlocking thing very, very swiftly. And occasionally, in the hollows that are vertical, you can place some reinforcement. Now, this reinforcement is what it leads to what we call confined masonry. Confined masonry simply takes care of any lateral loads that occur due to wind loads and earthquake loads. So, but the vertical gravitational loads are taken by load-bearing blockwork masonry. So this is the system, the way it works. Very little steel is consumed. We have built prototypes with this kind of construction, and we have found, you can see the process of construction, how it goes. And, you can do floor to floor in about 10 days or 12 days cycle, which is really quite quick, given our kind of construction. And if you're building 4 to 5 stories high, this really means that within 7 to 8 months, you're done with the total building. But when it has been tested in a lab, the entire system has been tested, and what we're able to establish is that you don't need more than 23 kilograms per square meter of built area of reinforcement steel for earthquake-safe 4 stories high construction. Very low embodied energy as a result. And because the unit of this block is small, it's only 30 centimeters long, depending on the thickness, it's either 30 centimeters long or it is 34 centimeters long. But this unit is small enough for you to be able to work out different kinds of housing layouts, different sizes of flats, using this module of construction. So here is an example of how you can arrive at different kinds of housing blocks. But this is like a precast industrialized product, very low investment in its production, but very versatile and increases productivity enormously and also materially very efficient. But there is no housing without a sense of community. This is the project in Ambur that we were referring to in Tamil Nadu, where community identity is extremely important. You're not building just homes as numbers for people to live in, you're building communities. So urban form of streets and courts with 4 to 5 stories high buildings produces a very urbane, a humane environment that everybody can relate to. It gives you shaded pedestrian priority. It also incorporates on the ground floors in some areas, markets, and also work from home possibilities. And if you have 400 to 500 homes, you can have environmental resilience. You can have enough soft ground for runoff, rainwater runoff absorption. You can have holding ponds for extreme climatic events. You can have connection to, and you can connect those ponds to natural channels. You can have plenty of plantation because there's some open space left. This is what 4-story building does for you. It's compact and yet it gives you a fair degree of open space too. And you can have site level water supply management, site level wastewater treatment and recycling, site level organic waste gathering and composting that can be recycled into urban agriculture too. And so, with decentralized utility systems of water supply, sewage treatment, recycling of water, and even electricity supply with solar PV now coming in, this is the future of urban housing, which is affordable. This can then be connected to the main trunk of the city when it becomes available in the future. These technologies are available and they're actually being implemented. So, affordable housing challenges this. You have to reach the threshold of affordability according to what people can pay for today, right? There's an equalized monthly installment that people can pay so many dollars per month or so many rupees per month. You have to find a solution within that. And you have to look at the home and the neighborhood together. And you have to look at both of them in such a way that they provide the base for the aspirational range of the future, where people will find education, health, leisure, and commerce in the housing environments also. And this, my solution of the DNA of low-rise, high-density, is the solution for the future, in my opinion. It is about inclusive construction economy. It gives you resilience in urban living. It gives you environmental security and it is the building type that has the minimum operational energy, and there's a built-in resilience against extreme events. That's the solution for the future. Thank you.